Let's take a look at this problem, which is problem 9 on for 2021 exam 2. Let q of x be a continuous function defined for all real numbers. A portion of the graph of q prime of x, which is the derivative of q of x, of course, is shown below. And something I emphasize in my class pretty often is whenever you have a problem like this, where you are given a graph, you really want to pay attention to whether this is a graph of q prime or just q of x or q double prime of x. Depending on which one it is, the answer to the following problems dramatically change. So make sure you pay attention to which one. Here is q prime of x. Let's take a look at part A. Which of the following intervals is q of x increasing? And again, make sure you read the question. You want to circle all correct choices here. So there might be more than one choice. And of course, there is also none of these in case none of the choices are correct. Alright, so how do you actually do this question? Well, you want some kind of connection between q of x increasing and q prime of x, because all the information we're given here is about q prime, so we need to draw some connection between q of x increasing and q prime of x, and this is hopefully something you remember. Q of x increasing, you can think of it as corresponding to q prime of x being greater than 0. Now there's one caveat here that this correspondence isn't perfect, because if you think about something like f of x equals to x cubed, then f of x is always increasing because it looks like this. But here, when I try differentiating it, so when I look at f prime of x, I get 3x squared. So in particular, you see that at 0, so at right here, you see that f prime at 0 is 0 because x is 0 here. So even if your function is always increasing, there can be points where f prime is 0. So q prime doesn't have to be strictly larger than 0 at every point, but this correspondence is something that you really should keep in mind, and it's usually almost always true. So knowing this fact, let's actually try answering the question. So where is q of x increasing? Well, from 0 to 2, let's look at this function. Well, q prime from 0 to 2 is negative because you're below the x-axis here. So 0, 2 is not it. So 2, 4, so when I look at 2, 4, we see that q of x is above the x-axis. It's positive here. So 2, 4 is good. And 7, 9, well, when we look at 7, 9, we see that q prime of x is positive here. So once again, 7, 9 works as well. Now, one thing I want to point out here is that if I change the problem, so rather than q of x increasing to q prime of x increasing, then the answer obviously changes because this is a graph of q prime. In the case, you literally check whether you're increasing or decreasing. You're increasing here, you're increasing here, you're, for example, decreasing here. So just be careful on what they're asking. Let's move on to part B. Which of the following are critical points of q of x? So critical points of q of x, so critical point of a function, is where q prime of x is either 0 or is undefined, or where q prime of x does not exist. So by DNE, I mean does not exist. And let's go up and see where that's happening. So going back to the graph, well, I guess we really only have to check 4, 5, and 7. So let's just check whether x equals to 4, 5, or 7. We have q prime is 0 or q prime is undefined here. So going up, let's first check x equals to 4. Well, at x equals to 4, we see that our q prime of x is undefined because these holes are open holes here. They're not filled in. So q prime at 4 is not defined. So that's telling us going back down that x equals to 4 is a critical point. What about 5 and 7? Well, going up, at 5, we see that q prime is 0 here. So that is a critical point. Whereas for 7, q prime is positive here. So q prime is not 0 at 7. So the only other choice is x equals to 5. So we get the answer of 4 and 5 for the critical points among these. Now, just to consider one more variation, I can consider changing this to critical points of q prime of x rather than critical points of q of x. Now the question changes because critical points of q of x is when q prime is 0 or q prime of x is undefined. So critical points of q prime of x will now be where q double prime, so when I differentiate it one more time, is 0 or q double prime is undefined. So if I care about critical points of q prime, then now you want to see where the slope is 0 or undefined in this graph of q prime. So for example, when I look at 7 now, here this is a critical point of q prime of x, even though it's not a critical point of q of x. And the reason is because the slope is undefined here. When I look at the slope from the left, so slope from the left, you just follow the curvature here and just draw the tangent line following it. So slope from the left is the slope of this line. And slope from the right at 7, well, you have this kind of parabola to the right of 7, and we see that just following it, we see that slope from the right looks something like this, and clearly slope from the left and slope from the right do not agree. So I guess when I say the slope, I mean it's really, I'm drawing the line, the tangent line where I only consider things from the left, tangent line where I consider only the points from the right, and we see that the slopes are not the same. So at 7, q prime is not differentiable. So 7 would be a critical point of q prime of x. So again, the wording of the question matters a lot. So make sure you are careful. Let's move on to C. At which of the following values of x, those q of x have a local maximum? So let's remember what local maximum looks like. It looks exactly like this. So you have something like this. I guess I should also point out that you don't have to be differentiable here at the top. It's also completely fine to have something like this. So where you have a sharp turn, where the slope from the left and slope from the right are not the same. But either way, you have a local maximum. But what really characterizes local maximum is when I look at the value to the left of it, q of x is increasing here. And when I look at all x to the right of it, then here q of x, so here q of x is increasing and here q of x is decreasing. And we see the same thing even when it's a sharp turn. Q of x is increasing from here to here, then it's decreasing from here to here. So how you can find the local maximum is when q of x goes from increasing to decreasing at that point. So that's the kind of x that we want to find. But here again, we're given a graph of q prime, not graph of q. So here what you want to find is where q prime of x changes from positive to negative. Because q prime of x changing from positive to negative is exactly the same as q of x changing from increasing to decreasing. So this is what you are trying to find. So let's check one by one. So you want to check 4, 5, and 7. Well, let's see what's happening in each one. So here at 4, what's happening at 4? Well, q prime of x is going from positive, it's positive here, and at 4, we are in fact switching to being negative. So you are actually going from positive to negative, so 4 is good. So 4, we in fact have a local maximum. What about 5 and 7? So let's go back up. 5 and 7, well, at 5, you are going from negative q prime to positive q prime. So here you do not have a local maximum. In fact, what you have is a local minimum. Because what this is showing us is that q of x is going from decreasing, q prime being negative, to increasing, q prime being positive. So your q of x looks something like this. You're going from decreasing to increasing. So here you actually have a minimum. So 5 is not correct. Finally, the last choice is x equals to 7. So let's see what's happening at 7 here. Where does q prime go from being positive to negative? Well, it certainly does not. It's positive to the left, positive to the right. So here you don't have anything. You don't really have a local maximum. So the only choice that's correct is x equals to 4. Let me add 2 quick comments here. When I say q of x is increasing to the left and q of x is decreasing to the right, all I mean is that nearby this local maximum, that's what's happening. Far outside, far away from this local maximum, anything can happen because all we want is a local maximum. So if q of x, remember, looks like this is a local maximum. Even though technically there are values very far away, like say this point, that has higher y value than this point. But that's okay because when we zoom in and we only consider the points locally, only consider the points nearby, then this is in fact the peak. It's the largest one. And the second point I want to make here is that if I change this problem instead of q prime of x to now this was a graph of q of x, then again the problem changes because for example 7 here would clearly now be a local maximum. You have a peak nearby, that's exactly a 7. So again, when the fact that this is q prime matters a lot.